potential. First, it is a scalar quantity. Now, what do we mean by scalar quantity? By scalar quantity, we mean that it does not have any direction. Okay, it does not have any direction, and it will be added directly. It can be positive, it can be negative, or as well as zero. SI unit of electrostatic potential is what? SI unit of electrostatic potential is volts. Okay, 1 volt is nothing but 1 joule per coulomb. In our last class, we have seen. Yes, am I audible? Hello.
Sir, you're audible, sir.
Fine, fine. In our last class, we have seen that potential is nothing but the energy in bringing energy in bringing 1 coulomb of charge from infinity to a particular point. Okay, that is called potential. Whatever energy we are using to bring that 1 coulomb of charge from infinity to a particular point, it is called the potential of that point. Okay, so if the energy is 1 joule for bringing that 1 coulomb charge from infinity to that point, then the potential will be called 1 volt, 1 joule per coulomb. Okay. Okay. Now, electrostatic potential due to a positive charge is always positive, and due to negative charge, it is always taken as negative. Next point, potential at infinity is always taken as zero, because we assume that the influence of charge is limited. Influence of charge will not be experienced at infinity. At infinity, uh, the net influence of charge will always be zero. Okay. Next, it follows principle of superposition. You understand what is principle of superposition? Yes. Hemant?
So we can say that if different charges are present.
No. Principle of superposition, I am saying. By principle of superposition, we mean that the potential will be directly added up. V equals to V1 plus V2 plus V3. If we need to find out the potential of all the charges taken together, then we will directly find out the potential of each charge and add it up. Okay, that is called principle of superposition. Next point, potential decreases in the direction of electric field. Okay, anything to note down, or shall we move ahead?
Sir, copy it, sir. Okay. We can move, sir.
Next is potential difference.
Speaker
Now here comes the important point. Actually, electrostatic potential, absolute electrostatic potential is not defined. We can only define the potential difference. Potential difference between 2 points A and B. What it will be? The potential difference between 2 points A and B is nothing but the work done. Work done in bringing unit positive charge or any kind of charge from point A to point B. Whatever work is done, that work will be stored in the charge itself, and this will be called potential difference. So potential difference is total work done in bringing a unit positive charge from point A to point B. If instead of unit positive charge, if we are taking any charge, then what will happen? Then we will be dividing it by the magnitude of charge. The total work done will be divided by the magnitude of charge, and we will get the energy required per unit charge. That will be our potential difference. Okay, got it now?
So got it.
So here from A to B, this work done will be given by integration A to B F dot dl. Okay, F dot dl means dot product between the displacement and force.
My spiral book
Distance
came out.
force into displacement. F dot ds was the work done in work, power, and energy.
Spiral book is
Got it?
right on
Remember?
that. Sir, yes, sir.
Shall we move ahead? Take it taken down.
Sir, copied, sir, yes.
Now, see this. Whenever a charge is kept in an electric field, then what will happen? A force will be acting on that charge, and that force will be equal to charge multiplied by the electric field.
And
Okay, Q into E.
house it.
Therefore, work done will be what? Q into E dot dl. QE dot dl. Now Q is 1 coulomb because we are calculating for 1 coulomb. So what will happen? Force will be equal to 1 into electric field. This one is 1 coulomb. This is for 1 coulomb. Okay. 1 coulomb into electric field. So force is nothing but electric field. So instead of F dot dl, we can write E dot dl. Therefore, work done by electric field when we are moving from A to B is E dot dl. Got it now? E dot dl integration A to B. This is potential difference between B and A. VB minus VA equals to integration A to B E dot dl. Okay, taken?
Copied, sir, yes.
Now, see now, the difference of potential was what? The difference of potential was the work done by external force, not by the electric field. It was the work done by external force. Therefore, the work done by external force will always be negative of the work done by external field. Negative of the work done by the electric field. Okay. So if the unit positive charge is to be moved against the electric field, means someone is moving, then it is external work. Then the work done will be A to B, external work will be minus integral of A to B E dot dl. This is the potential difference. Got it now?
Got it.
Now, see, always remember, electric field, if the charge is moved against the electric field, then we are doing positive work. We are doing something, means we are doing positive work, but electric field is doing negative work. And if the charge is moving on its own along the electric field, then electric field is doing positive work and we are doing negative work. Okay,
Yes,
remember
sir.
this thing. These 2 points, this red and this blue point, they are important. Okay, just remember that. Now, some properties of conservative forces. First property, work done by or against the conservative force depends only on the initial and final position. Next, it does not depend on the nature of path between initial and final positions of the body. What does it mean? It means that the we whatever we are doing here, we will calculate work done only with respect to final position and initial position. In between what is happening, we are not concerned with that. Okay. What is the nature of path? We are moving across a circular path, or we are just going in a straight line, or we are following a parabolic path. This is not our concern. Our work, final work done will only be calculated from the initial position and final position of body. Okay, got it?
Got it, sir.
Now, work done against the conservative force in a round trip is zero. Work done against a conservative force in a round trip is always zero. Why? Because initial and final positions will always be same. Now, see this example. If potential at point P is given by this much, potential at point P is minus 5x plus 3y plus 15z volts, then find out the electric field at x comma y comma z. Now here one thing is to be remembered, that the electric field is to be calculated, and integration of E dot dl will give us what? Integration of E dot dl will give us potential. It means a small potential change is nothing but minus E dot dl. From here we are getting electric field as negative differentiation, negative differential of voltage. Negative differential of potential difference will give us the electric field between these 2 points. Instead of dl we can write dr as well. And now if r equals to xi cap plus yj cap plus zk cap, then electric field will be partial differentiation with respect to x plus with respect to y plus with respect to z. With this knowledge, just calculate the above question. Yes, solving it, Heaven.
Solving the problem. Potential at the point B is minus 5x plus 3y plus 15. Then branching electric field of B XYZ. So we can say EX is 5 EY minus 3 EZ as minus 15 EZ. Sir, sir,
Yes.
EX 5 EY minus 3 EZ minus root 15 again.
See,
So what can it be?
answer will be 7 Newton per coulomb.
Yes, sir. Resultant I also got 7.
Yes, you are also getting 7 minus 5 I cap plus 3 j cap plus 15 k cap. That's it. This should be the answer.
Wow. Yes, sir. I also got same answer, sir.
Good then. How to do it? Just partially
Partial difference.
differentiate it every time. Okay, when you differentiate it with respect to x only, x component will be remaining, others will disappear. Why? Because it will treat them as a constant. Similarly for y and for z. Hence the electric field we are getting at 7 Newton per coulomb. Now, next question. In a region, a constant electric field is present, which is given by this much 2 I cap plus 3 j cap plus 4 k cap. See, this is the electric field which is given to us already present in this region. Find the potential difference between the points A and B. Solve it now.
Which is very like I'm not sure. Minus 12 we can yeah, little bit more.
Minus
12 cents.
minus 12. See, first of all, between the 2 points, we need to calculate
Position
the
vector.
potential difference. First of
Okay.
all, we will have to calculate the position vector. Very good. Position vector is I cap plus 2j cap plus k cap. So what will be the potential difference? Potential difference is E dot R, means dot product of electric field and the difference, the difference in their positions. Position vector. Okay, position vectors means displacement vector. Final answer is 12 volts. Very good. Next is potential due to various charge distribution. Now here we will be calculating potential due to point charge, potential due to ring, potential due to infinite charge sheet, like that. Okay. So first of all, potential due to a single charge. Because of a single charge, the potential is nothing but kq by r. Now how to find the potential? Its derivation is sometimes asked in boards. Okay. So just we shall try to understand that. Consider a point charge capital Q. Let us find the potential at any point P situated at a distance small r from the point charge. Now how to calculate that? Now from the definition of potential, what is the potential at point P? Potential at point P will be total work done by the external force from for bringing that charge from infinity to the point P. Okay. Now if we are bringing a charge small q, or let us say q naught, then what will be the potential? Then the potential will be given by dividing the total work done by magnitude of charge that we have seen. That's what we are doing here. F dot dr divided by q. Now what is F? What is the force which is being applied over this charge? Force that is being applied is q into E. It means what? Work done will be q dot E, qe dot dl. Okay. Now what will happen? This dot product will give us cos theta, E dl cos theta. If the charge is moving along the electric field, then this cos theta will be what? Then this cos theta will be 1. So E into L, that's it. E dot dl, that's it. Okay. Now, important thing is that if theta is not 0, then we will have to consider the theta. We will have to consider the value of cos theta. Okay, getting it? Now, through this, we can easily see the potential difference between infinity and a particular point P because of a point charge. Okay. What will happen now? What is the potential difference between initial point infinity and final point P? So Vp minus V infinity, see this, Vp minus V infinity equals to integration of E dot dl r to infinity. Now what is E? What is the electric field? Electric field is kq upon r square, dot is there dl cos theta. Okay. When we will do upper limit minus lower limit, we know that at infinity potential is assumed to be 0. Okay. So k is constant, q is constant, 1 upon r square will be integrated like this, and ultimately we will be getting kq by r as potential at any point r because of a single point charge. Okay, got it? Yes, Hemant.
I got it, sir.
From which point you need to take down? Yes, from which point you need to take down? Hello. Yes, Hemant, am I audible?
You're audible, sir. I see.
Yes, from which point you need to take down?
So from this point on, I said that one diagram then for it. And copying.
Fine. Just tell me when to scroll.
Then copy.
Copy. Done till this point.
Copy it, sir. To this one. Sir, copy it.
Copied. Now, now, if see the potential from here, we can see through this formula that potential is inversely proportional to the distance. It means if we are going to draw the graph, if we are going to draw the graph of potential with respect to the distance r because of a charge, okay, distance r from a charge and the potential at any point p. If we are going to draw that graph, the graph will be rectangular hyperbola. Okay, this will be rectangular hyperbola. Why is it rectangular hyperbola? Because the potential y-axis is proportional, inversely proportional to r, means x-axis. So y is inversely proportional to x, or we can say x into y equal to constant. This is the condition for rectangular hyperbola. Okay. So always remember that if the charge is positive, graph will be like this, the upper graph, and if the charge is negative, the graph will be the lower one, second. Now, due to various point charge, potential due to various point charges will be directly added up. Why? Because it is a scalar quantity. Because it is a scalar quantity. So potential due to charge 1, due to 2, due to 3, 4, 5, 6, all of these potentials will be directly added up to give us the final potential. That is nothing but principle of superposition. Okay, take it down, write it. Due to potential due to various point charges. Done.
Done, sir.
Now, same formula in vector form will become what? It will become like this. Means instead of r, we will write now r vector. Okay. Yes, done. Heman.
Done, sir. Yes.
Now, based on the principle of superposition, see this question. Question is, a charge of 2 microcoulomb is taken from infinity to a point in an electric field without changing its velocity. If the work done against the electrostatic force is minus 40 joules, then find the potential at that point. Calculate it. Answer is minus 20 volts, and it's very easy question. How? We know that potential is work done divided by charge, because potential is nothing but work done per coulomb. That's it. Work done per coulomb. So total work done is given to us, that is minus 40 joules divided by 2 microcoulomb. Answer will be minus 20 volts. Got it now? Yes,
Got it,
got it,
sir.
Hemant.
Got it.
Now see the next question.
The series of network and current fields directly protected ranging users.
Yes, question. You got the question?
Very good.
Yes, done this question. You got any answer?
Here we get from here. It's 60,
Yes. What is the answer?
60 we can get this.
60 microjoules.
Yes, a system
60
microjoule.
microjoules is the answer. Yes, this was easy question. Not that much time was required. Okay. Just conservation of energy. We have to use a conservation of energy. Means initial kinetic energy plus potential energy will be equal to final. Now, when you are taking it to the final infinity, final point which is at infinity, then the potential energy will be zero. Then what will be the kinetic energy? Full potential, initial potential energy will be converted into kinetic energy. That is 60 microjoules, charge multiplied by potential. Next point. Calculate the potential at point C. C is the center. Calculate it fast now. You have 2 minutes. Okay. You have 2 minutes. Calculate it fast. Just calculate it. I am just coming from washroom. Okay. Hello.
So,
Hello. You got the answer? Hello. Yes, Hemant. Am I audible?
yeah, you're audible, sir.
Fine. You got the answer. What is the answer?
One mic champion.
One by?
We can see.
Answer is zero.
Sir, I got some zero, sir. Once.
Huh?
Sir, answer is zero, sir. I thought.
Okay. You also got zero. Fine. If you got zero, then it's fine. How? Why is it zero? Because potential is a scalar quantity. Because of negative charge, potential will be negative, and because of positive charge, potential will be positive. Total charge is zero. That's why potential is C plus Q plus 4Q. 5Q it is. Minus 3Q minus 2Q minus 5Q it is. So total answer will be what? Zero. Now similarly, other questions are also there. Now, for having continuous charge distribution, how to calculate continuous charge distributions? See, because of charges, the potential will be there. But till now we have seen point charge. But if the charge is continuous, means the charge is spread over a sheet or an conductor rod or a sphere or anything, any symmetrical object or unsymmetrical object, then how to calculate that? Then we will follow two ways for finding potential. First of all, always remember, if the formula for electric field is very tough, then we will take a very small segment and then we will integrate, then we will find it out. Okay, we will find it out. What is the potential? Means first we will calculate the potential due to very small element and then we will integrate. But if we know the electric field, then potential is what? E dot dr. Then we will use this formula, electric field dot dr, and then we will integrate it. Fine. Now, potential due to a ring. What will the potential due to a ring? For this, we will take a small element and we will find potential at the center due to that element. What it will be? Potential is see, potential due to the small element will be directly added up for each and every element. So if we are taking the small element, then potential due to that will be k dq by dr. What is dq here? Dq is the small charge which is considered on the element. Therefore, potential due to full ring will be integration of this small potential dv or k dq by r integration. K by r will come outside. Integration of dq is nothing but q, full charge on the ring. Got it now? Easy this was.
Got it.
Yes, Hemant?
Got it.
Fine, fine. I'm sending its PDF to you. Okay.
Yes.
Okay, then that's all for today. Oh my god, it's taking too much time. Okay, I'll send it to you as soon as as
Yes,
soon
sir.
as it it will be converted into PDF. Okay.
Yes, sir. Okay, sir.
Okay, then that's all for today. Thank you.
Thank you, sir. Yes,
Our class is there at 7:30. Okay.
yes sir. Okay.